Hello, today we're taking some notes, our first set of notes. You should not only have access to this video, but you should also have access to the copy of the notes that are posted in the assignment. You should open up this in Google Slides. You're going to fill out all the green boxes. Now, there's one place that I forgot to put a green box, so we're going to have to copy one of these and put it in. So first thing I'd like you to do is go down to the bottom of this page. Grab this green box right here, hit Control C, Control V, and drag that box right over here. So anytime you accidentally delete a box, you are expected to replace it, put it back in, and anything that you see in green, you have to fill out. That is the expectation here. So first thing you're going to do is you're going to put in your name. I'm going to put in Mr. Passon. Today's date. So for me, when recording this, it is August 5th, 2020. And for me, this is the first period of the day. All right. Now, we're talking about the number system. Okay. So when we're talking about the number system, we want to talk about, well, what's that mean? Well, the number system is a way that we classify numbers. So the number system classifies numbers based on their types and characteristics. So we're going to talk about different types of numbers. Now I'm going to skip down and we're actually going to start here with the natural numbers. Those are our counting numbers. Now in this school year, we're actually going to focus a lot more on integers than we do on the natural numbers. But the natural numbers are counting numbers. And when you start counting from 1. So it's going to go 1, 2, 3. And you'll notice those are also the positive numbers. So these are going to be our positive integers. All right, so our examples. Again, there are counting numbers. So they're going to be 1, 2, 3, 4. And they're just going to go on forever. Feel free to go ahead and put in your own large number up here. As long as it doesn't have a decimal in it, you're okay. So the whole numbers are a little bit bigger than natural numbers, but just a little bit. It's all the positive counting numbers starting with 0. All right, so here we're just going to go 0, 1, 2, 3, 4, dot, dot, dot. And then we can put in our own very large number if you'd like, any whole number as long as it doesn't have a decimal in it. All right, so what we've thought of is the natural numbers are our sort of smallest set of numbers. Then our whole numbers are a little bit bigger. They just have that added number 0. Then integers. Integers are the new concept that you dealt with a little bit. It's where we take those whole numbers and we look at sort of their opposites. So when we're talking about integers, we're thinking of both positive and negative numbers. And we're going to have a lot of problems where our answers are negative. And if you come back and say, oh, well, that can't happen, I'm going to have to most of the time come back and say, no, our answer is negative. So if we're taking away more than we have, we're just going to get a negative answer. Okay? Now, examples of those, well, any positive whole number, any number that we've already written, and then we can take its negative. So we have negative 4, comma, 17, comma, negative 17, comma, negative 10, comma, fill in 3 or 4 more numbers on your own there. Now we're going to talk about the rational numbers. And remember, you can pause anytime if you need a little bit extra time to fill in your answers. So numbers that can be written as a fraction. All right? Now, that's the real big definition. But any number that can be written as a fraction, if we write it in decimal form, it's either going to terminate, meaning it's going to stop, or it's going to repeat and repeat on forever and ever and ever. So it's terminating decimals and repeating decimals. Now let's make that box a little, oh, I don't even need to write the word decimals because it's already there. All right, so let's go ahead and write one of those. First, let's write a fraction. Well, any number can be written as a fraction, or any whole number can be written as a fraction, because 5 equals 5 divided by 1. 5 over 1. So there's our first example. We could do that with a negative number. negative 17 over 1. So negative 17 is also a rational number. Now let's write something that can only be written as a fraction and can't be written as a whole number. Let's write 3/4. Or we could do negative 5/6. Right? Now we could write a decimal. 12.5. This one terminates. By terminates, I mean it stops. Another one we would write is like 3.545454545454. And normally we're going to write one of two things. We're either going to put a line over the repeating part, or we're going to put those dots at the end to tell us that it's repeating. All right? So let's talk about our different types of numbers again. We've got our natural numbers. Those are our counting numbers. Our whole numbers, which is the amount of like things that we can possess. So here we're going to have zeros. Then we've got this new idea that was introduced much later, where we have this idea of negative numbers, where like say we could owe someone money as well as just having money. So that's what we're dealing with integers, where we have this idea of this positive number, and we can extend it in the negative direction. So we're going to be doing a lot with integers this year. You guys are going to have to get real comfortable with that negative sign. Then finally, rational numbers. Now again, the key definition is that it can be written as a fraction. But if it's written as a fraction with an integer on top and bottom, then when we put it in decimal form, it's either going to stop, and that's going to be called a terminating decimal, or it's going to repeat that same pattern over and over and over again. All right? So now we've talked about all our different types of numbers. All right, so let's go ahead and figure out what this is as a decimal. Now, we're going to do that. I'm going to use my little whiteboard here. I expect you should also always have a pen and paper to write down some of the scratch work beside your notes. All right? So I'm going to go ahead and write a little division bar here. The top number always goes inside. And yes, writing with this little marker is insane. All right? And that's my weird decimal point. So we ask how many times does 6 go into 50? It goes in 8 times. We get 48. Then how many times does, so that's a remainder of 2. And we ask how many times does 6 go into 20? Goes in 3 times. That's going to be 18. So I get a remainder of 2 again. Anytime I get the same remainder, I'm going to get the same thing that goes on and on forever and ever and ever. So now I'm going to click back to my cursor here, and I know that my answer is 0.8333. And I'm going to use that ellipsis, that dot, 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 to let us know that it goes on forever. I'm going to erase that work there. And do we call this one terminating or repeating? Good. It is repeating. The 3 is repeating. We're going to do the exact same thing, all right, with the 2 and the 11. So we've got the 2 on the inside, the 11 on the outside. We're going to think of it, it goes in 0 times, and we're going to think of it as 20. So 11 goes into 20 one time. Then we get our 9, bring down our 0. 11 goes into 9 8 times, and we get 88, and we get 2, 0 again. So that's going to go in 1 time. So it's repeating, and it goes, oh, wrong tool, 0.181818, still following that same pattern over and over and over again. So this one is also repeating. Okay? Now, this other one, I'm going to take a slightly different approach. Alright? I want this out of 100 because I know what the hundreds place is. So I can multiply the top and bottom by 5. Okay? And that's going to equal 85 over 100. Which I know my decimal places. So I can put that in as 0.85. Note that this one does not have that same repeating pattern. It just stopped because my remainder was 0, because it was in a power of 10. So this one is terminated. Okay. So let's focus on the whole numbers, the integers, and the rational ones to fill this table. So we're going to think of what types of these numbers contain all the other ones. What's this biggest box here? That's going to be our rational numbers. Oh, numbers. Then we want the larger set. So which is larger? The set of integers or the set of whole numbers? Well, the integers include all the whole numbers. We're going to have the whole numbers here. Now, if we had another box inside of here, and you can draw it if you like, that would be drawing a little text box in here. You could write the natural numbers. And that is our smallest set. And I'm going to change the size on that so it actually fits in there. The natural numbers. All right. So let's read our question. Is it possible for a number to be both whole and an integer? Well, let's look at the definition of integers. The set of whole numbers and their opposites. So, yes. Why? Because the whole numbers are integers. And again, remember, you can pause this at any time you need to catch up. Alright, so now we're going to go ahead and go on to page 2. Alright, so we're going to review the process for adding and subtracting positive fractions in the table. So we're going to look about adding fractions. Okay, we need to find a common denominator. Now I'm going to pull this up. I don't know why it's writing so far below the line. And then we're going to add the numerator and keep the denominator the same. Alright, now writing fractions here is not the easiest thing to do. Alright, so we're going to write fractions where we write the top number slash the bottom number. So we're going to do 7 divided by 8, that's our fraction, plus, and let's convert this from a mixed number to a fraction. So that's going to be 2 times 1 is 2 plus 1, that's 3 halves. Alright, now, can we just add these straight across yet? Think about it. No, we can't, because the denominator isn't the same. So let's find a common denominator. That's 8. We're going to multiply the top and bottom by 4 here. So we're going to get 12 over 8. So we've got 7 over 8 plus 12 over 8. That's going to be 19 divided by 8. And if we wanted to write that as a mixed number, that would be, well, 8 goes into 19 2 times. And that's 16, so there's a remainder of 3 left over. So 2 3/8. Alright. Now let's talk about how we subtract fractions. So again, we find a common denominator. And this time we subtract the numerators and we keep the denominator the same. Alright, so let's go ahead and look at this one. That's 2 times 4 is 8, 9, 10, 11. So that's 11 fourths minus 2 thirds. We need a common denominator, so we're looking for multiples of 4 that are also multiples of 3. 4, 8, 12. 12 is a multiple of both, so we're going to put them over 12. Alright, so that's going to be 33 over 12. See, I multiplied the top and the bottom number by 3. minus, and here I'm going to multiply the top and bottom by 4, so I get 12 on bottom, 8 over 12. So I know my answer is going to be over 12. And by the way, I'm going to hit the insert key every so often, so when I write, oh, it doesn't help here, never mind. So let's go ahead and do 33 minus 8, that should be 25. So we've got 25 over 12, which is equal to 2 and 1/12. Okay, we're going to do the same thing for decimals. Alright, so we're going to rewrite the problem. So let's talk about how we add or subtract decimals. We're going to rewrite the problem vertically. Line up all the decimals and fill in the placeholders. Alright, so we're going to write, now I'm going to leave myself a little bit of space, so it's 268.97. Now, put a little single quote before you put the plus, otherwise it's going to use that a little bit differently, and then we're going to line up everything. So I need the 3 under the 6, 38.659. Alright, notice that I need a placeholder in my upper number here, otherwise they don't line up. Now I'm going to hit enter here to get my next line, and I'm going to make this underline so it looks like a regular addition. So let's look at our places. Look at places that we're going to carry. Alright, so I'm going to grab my other tool here. Well, I guess this first one I don't need it yet. So there's 9, right? And then 5 plus 7 is 12, so we're going to carry the 1. 15, 16. Carry the 1. 16 plus 1 is 17. Carry the 1. 9, 10. Carry the 1. 3. So we get something that looks like this. Now, to do this a little bit nicer, I would write it out on paper, and we might switch to that in the future if you guys have any trouble with this. So here again, we're going to rewrite the problem. So how do we do subtraction? The exact same way. We're going to rewrite the problem vertically. We're going to line up all the decimals and fill in placeholders. Alright, so let's start with 870.45, and then we are going to subtract 96.38. Alright, I'm going to make that underlined, of which, by the way, Control U is a quick way to underline. And we're just going to look where we need to borrow, where we need to regroup. Alright, so I'm going to notice here I'm going to need to regroup. That 4 is going to become a 3, and that's going to become 15. So 3 space 15. 15 minus 8 is 7. 3 minus 3 is 0, so it's going to be 0.07 on the end there. Here I need to cross out again. 70 is going to become 60, and this is going to become 10. So 10 minus 6 is 4. And then 86 minus 9. So 7, and then 16 minus 9 is 7, and then 7. So 774.07. Now I'm going to sweep that out of the way and just put my answer down. Oh. Alright, I decided to make things a little bit bigger so we could do that again and actually do that a little bit more accurately. And in fact, I think I'm going to zoom in just a little bit more. So, view, zoom in. Alright. Hopefully now I can use my pen a little bit better. So 4, 3, this becomes a 15, this becomes a 7, this becomes a 0, decimal, decimal, 7 becomes a 6, this becomes a 10, this becomes a 4, 8, 7, 16 minus 9 is 7, and 7 minus 7 is that. So, when we pick our value, we get 774.07. There we go. So, again, you can get that feature by zoom, zoom, and then we're just going to zoom out. So that's Control-Alt-minus is how we're going to take care of that. Control-Alt-minus, minus, and then we're just going to readjust our page. So we're right there on center. Alright. So now practice. You're going to take a few minutes. I'm going to stop here for a little bit. And then we'll come back to go over the answers and to share yours. So you should be trying these for the next 5 minutes. Pause the video here and then complete these 6 problems, and then we'll come back. Okay, so you should have all 6 problems done. We're going to go over them real quick. If you did not get them right, go back and rework them. First, we need to find a common denominator. So this is 27 over 8 minus 3 over 2. Alright, so it looks like our common denominator is 8, so we've got 27 over 8 minus, let's multiply the top and bottom by 4, that's 12 over 8. So 27 minus 12 is 15 over 8, which equals 1 and 7/8. Let's look at this one. Alright, we want to line them up, so that is 168.45 plus 67.3, and I'm going to put in that placeholder, add a little space here so everything lines up. Make it underlined so it looks pretty. Get rid of my underline. And let's look at, well, these last two. It's going to be 7, 5. 15 here, and we're going to carry the 1. So 12, 13. Carry the 1, 2. So we get 235.75. Alright, let's look at this one. Our common denominator is going to be 10. So we're going to take 5 times 6, 30, plus 3 more. That's 33 over 5, plus 39 over 10. And let's just do 66 over 10 plus 39 over 10. That's going to equal 105 divided by 10. Both of those are divisible by 5, so that's going to be 21 over 2, which is also going to equal 10.5 or 10.5. Alright, let's, screen jumped on me. Don't know why I did that. Let's get in here. So now we're going to do subtraction. So we've got 249.6 minus 58.07. So we need to add a placeholder here so everything lines up. Let's get this underlined. The 60 is going to have to cross out. And we're going to get a 5 up there. So we're going to have 53 here. So 0.53 at the end here. Then we're going to have a 1 here. And then we've got 24 minus 5. That's going to be a 19. So we're going to have 191.53. Let's check out this one here. We've got 5 divided by 6 plus 7 divided by 12. What is our common denominator? It's 12. So we've got 10 over 12 plus 7 over 12. That's going to be 17 over 12, which is more than one whole, so it's 1 and 5/12. Last one for the notes for today. We've got 334.16 minus 95.03. Everything lines up today because they're both into the hundreds place. That first subtraction is going to be 3. That second subtraction is going to be 1, so it's going to be 0.13. Let me not make that underlined. Then we're going to have cross that out to get this one here. So we're going to have 14 minus 5. That's going to be 9. Alright, then we're going to have 32 minus 9. That is 23. So it's 239.13. And looks like I've got a space somewhere, but maybe not. So it looks like everything lines up there. Alright. So those are our notes today. We're reviewing some basic skills, how to add, subtract fractions, how to add, subtract decimals. We'll be talking more about positive and negative numbers. I'd like you to give me your summary for the lesson today. So go ahead and do that here. And then on slide 3 is your classwork, your practice assignment. Okay? Then you'll notice you also have an ALEKS assignment. And we'll be going over that. You'll have multiple tries on that, and you'll see the deadline when you look into your ALEKS page. Thank you. Have a good day, guys. Good luck.